Building AI is complex. Lessons from the Human Brain, reading the amusingly informative Bill Bryson's latest book, The Body, A Guide for Occupants, has proved to be a productive and enriching way of getting through the COVID-19 coronavirus lockdown period. After covering our core components, Chapter 1, Our Skin and Hair, Chapter 2, and the World of Microbes and Viruses, Chapter 3, written before knowledge of COVID-19, but with ominous foreboding, Bryson turns his virtual scalpel to our own brains, Chapter 4. With so much focus on creating smarter software through research and development in the field of artificial intelligence (AI), should we be looking to Bryson's cerebral, pun intended, analysis of the cerebellum to get some AI software development lessons from our own brain? He explains that for each visual input in your eye to travel down your optic nerve into your brain, it takes 200 milliseconds, which equates to 1/5 of a second, for the brain to receive, process it and interpret it. As fast as that sounds, 1/4 of a second is not an inconsequential amount of time if we need to dodge a car, punch or other fast-moving danger. Bill Bryson says, to help us deal with better this frictional lag, the brain does a truly extraordinary thing. It forecasts what the world will be like 1/5 of a second from now, and that is what gives us the present in our minds. That means that we never see the world as it is in this very instant, but rather as it will be a fraction of a moment into the future. In many ways, this working on stuff before it happens mechanic is what the software industry has already been trying to do with AI. Using big data analytics and today's complex algorithmic logic, computer scientists have been working hard to create so-called predictive analytics and autonomous automatic computing controls that fix things just before they're about to go wrong. Often based around a knowledge of previous behavior types and the ingestion of other similar or related, and some only tangentially related, datasets, the computer brain is being engineered to work according to Bryson's mandate for action 1/5 of a second in the future. From the body to computers, the question is, can we use this principle to build AI brains faster? Could these techniques even help us in our global quest for a cure for COVID-19? The difficulty is that large AI software programs are complicated to design and develop, and involve numerous types of data. This data is often hard to port from one platform to another, requiring several steps, powerful infrastructure and multiple different skill sets, ranging from feature extraction to data collection and analysis, as well as machine resource management, and that's to make even a small portion of actual AI and machine learning (ML) code. Your brain can store and process 200 exabytes of information, last Brian reference, honest, and exabytes are 2 steps up from terabytes after petabytes. Computers on the other hand are still somewhat behind this standard of information processing. Given the gulf that exists between human brains and AI, the information management task we have in front of us, what are we doing about it in the short term? According to Eduardo Aguilar Peláez, at least part of the answer lies in the cloud container, a portable chunk of software code that runs with all its own requirements in different places, orchestration platform Kubernetes. Peláez is a product manager at Canonical, the company behind the Ubuntu operating system. While the body performs many of its compute functions instinctively according the coded instructions in our DNA, computers need to do a whole lot of preparation on a far more manual, it's actually virtual basis. A lot of work needs to happen before we even get to the AI starting line, not to mention the effort once you've crossed it in order to keep applications and the supplementary code, and the data that needs to be ingested, all supported and up to date. To try and contain this challenge, Kubernetes has worked hard to step up and become a major catalyst in the shift from monolithic legacy IT to microservices, containers and multi-cloud. However, Peláez thinks that the platform really comes into its own with AI and ML through its ability to automate the deployment and management of containerized applications, including complex AI and ML workloads. So, why now? We've been on the cusp of mainstream AI adoption within the enterprise for a while now, and it looks like we're almost there, with the percentage of businesses employing AI having grown by 270% over the past 4 years. As more organizations turn to AI to reduce operating costs, uncover new revenue streams and improve decision-making, we'll no doubt see more teething problems with AI, ML lifecycle execution and management. This is where Kubernetes-based containers come in to help organizations kickstart and accelerate their AI-based initiatives, said Peláez. Contain yourself. Containers provide a compact environment for processes to be built, run and tested, scaled and reproduced across a range of IT environments including on-premises and multiple clouds. Large, monolithic applications can be broken into targeted, easier-to-manage microservices. Kubernetes-based containers are ideal for the job because AI algorithms must be able to be trained and then scaled to be optimally effective. The majority of deep learning algorithms and data sets require a large amount of compute. Kubernetes provides a solution to this because it is all about scaling based on demand. It also provides a way to deploy AI-enabled workloads over multiple commodity servers across the software pipeline while taking away the management overhead, said Pelaez. Once model training has been completed, serving them in a range of deployment scenarios, from edge compute to central data centers and public clouds, is tricky for non-containerized application forms. Again, Kubernetes can supply the necessary flexibility for a distributed rollout of inference agents on a variety of substrates. But Pelaez is realistic. He notes that, like our own brains, Kubernetes can throw up its own setup and deployment challenges. Lightweight, multi-node upstream solutions like micro K8s, with a small disk and memory footprint, can remove potential headaches and get K8s clusters up and running in little to no time. Strict confinement, automatic updates and available add-ons such as dedicated ML workflow toolkit Kubeflow, mean that developers can quickly set up, develop, test, deploy and scale AI and ML applications, especially those using them to help manage IoT devices, concluded Canonical's Pelaez. Brains made fun. Okay, so it's something of a stretch to go from Bryson's Brains made fun to open-source cloud container orchestration platforms for AI data competency. As a marketing slogan, it's terrible. But it does illustrate the way that we're looking to build information management into the world of software in an almost organic way in some areas. One of the reasons babies sleep a lot is that growing brain tissue is exhausting work. There's a lesson there for AI engineers burning the midnight oil, i.e., get some shut-eye guys.